All right, everyone. Welcome to day one of limits. We are going to be starting our first real calculus unit on limits today. And so you'll need two things. One, you'll need your books because I'm going to reference some things in the books. You want to make sure that you are following along with me on that. And also this guided notes page. So make sure that you can follow these guided notes while I'm filling them out with you. So the section one, I'm not going to go over with you right now. That is something that you can read on your own, and we'll discuss it in class when you come to it. What we will do is we'll go to section 1.2. So in your books, if you can turn to page 48, and then we are going to take a look at that first picture together, which I'll pull up, but it's nice if you have a reference to it. So let's start with limits. What is a limit, right? So a limit is something we are going to find the behavior as a graph approaches a certain value. So for example, let me pull up this picture, which is our picture of page 48 in your books. So as I mentioned before, we have, there's a picture over, which you can't see, but the picture that is in your book, there is like a parabola looking thing. And in that parabola looking thing, you'll notice that there is a hole. And there's a hole there because right below here on this, on the picture on this function right here, we know that if we were to plug in the number 1 for x, we would get a 0 at the bottom, which makes this function undefined. But we know that something's happening around that hole. We just don't know what's happening. And so what a limit does is a limit is going to tell us cases, especially of discontinuity, of holes, of asymptotes, what is happening to that function as it approaches or when it gets to the holes, the asymptotes, the jumps, etc. So that's what a limit is going to be doing. So why might this be helpful to us? Well, we're able to analyze where these discontinuities happen. We can actually analyze where these pieces are in a graph. So it helps us more determine the behavior of the function at a certain point, and it will really help us find more relative pieces to complex functions. And you'll see as we move forward, we are really going to get into the different stages of calculus. This is the foundation of calculus. So there are three approaches that we are going to study as far as finding the limit of a function. So one of them is going to be this table here. So I'm going to go over this table with you in a second. So one of them is actually just a good old-fashioned, it's called numerical data, just plug and chug, and we are trying to find the exact point of what's happening around this hole or this asymptote in this particular function. A second way is graphically, which I will show you in a moment. And the third way is analytical, which we are not going to do this today. We will go over this when I see you again. So if you flip your notes to method number 1, let me just show you real quick what is happening here in this page on your book. And then we're going to try this example with method number 1. So method number 1 is constructing a table of values to find the limit of a function. So really this is just a glorified t-chart. We're just plugging and chugging to find where is this function approaching. We know, like for example, in here, if we were to plug in 1 into this function to find out what the value is of this function at 1, it is, so that'd be 1 to the third power minus 1. So 1 to the third power is still 1. So 1 to the third, or 1 minus 1 gives me a 0. And then if you plug in 1 at the bottom, 1 minus 1 is 0. Well, we know that this function is not equal to 0 at the number 1, because you can see on this graph, it clearly is not equal to 0. It's undefined at this point. There's a hole. So using this chart will help us determine how close it's getting to this particular value. So if you use, so what you can see here, what they did was they know we want to find the value as it approaches 1. So the values they picked as x, as you can see, are getting very, very close to 1, but never hitting 1. So like 0.9 is really close to 1, right? And 0.99 is even closer, and 0.999 is even closer. So if we were to literally take these numbers, so 0.75 and plug it in, so 0.75 cubed minus 1 divided by 0.75 minus 1, we would get 2.313. And again, taking the 0.9, plugging it in, we get 2.7. As you notice, as we get closer and closer to 1, these values are also getting closer and closer to a particular number. As you can see here, these are approaching the number 3. And the same thing over here. So these numbers are just slightly above 1. So like 1.001. They keep getting a little bit further away from 1. So you're seeing what is happening to our y values as our function is approaching our whole that we have in our function. What's happening? It's actually approaching 3. It's not approaching 0 as it states in this limit up here. So what we're doing is we are finding graphically or finding numerically in a t-chart form, where is it approaching? Like what's it approaching as a y value? It's not approaching 0 as it states it would have. So let's see what this looks like in another context. So let's look at the example that I gave you. Let's get rid of this and go back to here. So the example I gave you, I'm going to go through this example. This is at the bottom of page 48. So it's exploration. It's like a practice that you can try on your own. So let me just kind of walk through this with you. You can probably hit pause and try it by yourself. That is what I would do, is use your calculators to make sure you're getting these same values. So that way you understand how to do this. You are going to have 2 problems like this on your homework, which is on page 55, numbers 2 and 3. So I'm going to show you how to do one like this, and then also how to answer the question. Right here tells you how to actually answer the question and finish the statement. So what we are doing for this one is we are trying to find the value of this function, x squared minus 3x plus 2 divided by x minus 2 as the function is approaching. So what is the limit as the function is approaching 2? So as we learned from the last example, if I were to plug in 2 here at the bottom, we're going to get 0. We're going to get undefined. So there's something happening at this graph around x equals 2, and we want to find what value are these as I get closer to 2 from both directions. What value is this going to get closer and closer and closer to? All right, so let's start here. I'm going to just do the first couple, and then the rest of them I'm just kind of fill in because it does get time consuming. This is really statistics, like plugging and chugging and finding numbers. So there's really not much to it other than making sure you plug it in the calculator correctly. Okay, so for 1.75, you're going to be putting in, so it'll be 1.75 squared minus 1.75x, or sorry, minus 3 times 1.75 plus 2. So if you do that in your calculator at the top of the fraction, that's what I would do first. You're going to get a negative 0.1875. Okay, and then, so you want to do everything at the top first, and then find everything at the bottom. So then 1.75 minus 2 gives you a negative 0.7 or 0.25, sorry, negative 0.25. So then if I divide those two out, I end up with 0.75. Okay, and so we're gonna do the same thing with 1.9. So 1.9 is gonna get plugged in here, so it'll 1.9 squared minus 3 times 1.9 plus 2. So if you do that in your calculator, you should get negative 0.09. And then 1.9 minus 2 is just 0.1, negative 0.1. So negative 0.09 divided by negative 0.1 is going to give you 0.9. Okay, so again, we're just going to continue to plug things in. So I'm not going to go over every single step from now on, but I strongly suggest that you just in your calculators, make sure you're getting the same answers that I do, because you are going to get points for making sure each box is correct. So here's the question mark, because we don't know, this is what we're trying to find. So as we get closer, now if I plug in 1.99 squared minus 3 times 1.99 plus 2 divided by 1.99 minus 2, I will get 0.99, so 0.99. That's supposed to be a 0. And then when I plug in this one, I'm getting even closer. Okay, so 0.999. Okay, so the question is, as my x values are approaching 2, what are my y values approaching? So you should see they're getting closer and closer and closer to the number 1. All right, so hopefully that's what's happening on the right side. So let's see what's happening over here as we are getting closer and closer from the right side or the other direction, the greater than side. So now I'll start with 2.25. So you plug that in, 2.25 squared minus 3 times 2.25 plus 2 divided by blah, blah, blah. Okay, you will get 1.25. Okay, 2.1, if you plug that in here, again, you should get 1.1. The next value will be 1.01, and look what's happening. It's approaching and getting smaller and smaller and closer to the number 1. That'll be 1.001. Okay, so that's what we're looking for here, is that your function, as you can see, is getting closer and closer to the same number on both sides. So it's getting closer and closer to 1. So that means there is a hole or something like happening around 2 comma 1. But again, if we were to plug in 2 here, we're getting 0. And that's not the case. 0 is not what's happening there. There's something happening and it's approaching the number 1. So we would fill in the last blank. Therefore, the limit as x approaches 2 for the function x squared minus 3x plus 2 over x minus 2 is 1. Okay, so this right here, these stars, this is the main idea. So when you're doing your homework on numbers 2 and 3 on page 55, you want to make sure that you wrap up your statement saying the limit as blah, blah, blah is approaching this is, and then what is the limit that it's approaching. Okay, let's move on to method number 2. Quit my drawings and let's scroll down. Okay, method number 2 is a little less intense because now we're actually just going to be looking at graphs and then seeing what is the limit looking at a graph. Okay, so let's start with this one. And I'm going to answer A and B. I'm going to skip C for right now because C is a little bit special. So here we are trying to find, as the limit approaches -4, what is happening at this graph. So we'll go, remember, these are x values. As limit approaches x equals -4. So we're looking at -4. So here's right what's happening. So as my, let me get my drawn. So here's my function, and here is where it's approaching -4. So it's approaching this hole. And so as it's approaching -1, what is, or -4, what is the limit? Well, the limit here is just the y value, which is 2. Okay, so the limit as we're approaching -4 is the y value of 2. All right, next, what is the limit as it's approaching 6? So x equals 6. So we'll go to x equals 6. So I'm following, oh, that's not, I don't want that because that is just, it's not a function. That is just my, well, I guess it is a function, but it's just one single point. I'm more curious about this, what's happening here where this hole is. Okay, so as my graph, the actual graph is approaching 6, what is the y value as it's approaching 6? It's 5. So the limit as your function approaches 6 is 5. All right, we're going to hold and pause on this one. We're going to come back to that one because there's a special case scenario we're going to go over. Let's scroll down and look at the next example. If you want to try this one by yourself, just try A and see how you do with that. So if you want to just take 30 seconds or even 10 seconds to look at the limit as it approaches 7, what is happening? All right, as it approaches 7, so on my graph here, this is what I'm looking at. Here's my graph at 7. It's approaching this hole here. And so what y value is this function approaching as x is approaching 7? It's the number 2. So the limit as this function approaches 7 is 2. Okay, now let's talk about some special case scenarios. So if you go to your the back, or actually your second page, there are 3 situations, and this is on your book on page 50. There are 3 limits that fail to exist. So if I were you, I would turn to page 50 right now so you can see a picture as well as me explaining it so you can draw your example. So the first limit that fails to exist is having a different behavior from the right as from the left. So what does that mean? So in the situation in your book, if you notice, they have a function, and it's kind of here, you have one this way, and there's like an open circle and another one here and an open circle. So what's happening, different right and left behavior, is as this is coming from the right, there's a different value for y as when the function is approaching from the left. There's a different value of y here. So this, remember, this is a jump. It's a discontinuity in the function. So this means that the limit does not exist. So this means that it is undefined, or just it fails to exist. So it's, yeah, you can just say undefined. So basically when you have a jump in your graph, it is undefined. So if we go back to our example number 1 that I did up here, reason why I skipped this one is because I wanted to make sure we went over that this did not exist. So if we look at the limit as it approaches 1, as your x value approaches 1 here, so here's my x approaches 1, I have a jump. So I have, as it approaches from the left side, it is approaching the value of 4, but as it's approaching the right side, it has the value of -2. So because there's a jump and a discontinuity there, this is undefined. So you can write undefined here because it has a jump within the graph. This is not considered a jump. This is just a different value at the number 6. But as you can see, the graph is still going. There's just a hole. You can have a hole, but you can't have a jump. Okay, let's go on to another example. So if we go to number 2 on page 50 is called unbounded behavior. So if you look at that example, you can kind of see that the two graphs, they're kind of like converging, but they're never going to meet. So what happens right there? You know, like if they're never going to touch that y-axis, what is that called? And hopefully we know that that is called an asymptote. So unbounded behavior basically means it goes on for infinity and they're not going to touch a certain position. So that would be considered an asymptote having an undefined limit. So here, if for example, B, there's an asymptote here. Both of these, this function here, as it approaches this way, as it approaches the number 1, it just goes off into infinity, and this one goes off into infinity, and it's unbounded. So there's never, like, it's never going to hit anything. So this would also be undefined. All right, so just to recap, when we have undefined, yep, spelled that right, okay. So when you have this asymptote or an unbounded behavior, or if you have a jump in your graph, like this one, where it jumps and there's a complete, jump here, this would also be undefined. All right, the last one, which I don't have example for you in this notes page, however, it is on page 51, is oscillating behavior. So the most common and probably widely used one that we're ever going to use, oscillating, if you look at that graph, it's the sine graph. So the sine and the cosine graph are considered oscillating behavior because they can keep going and going and going and going and going, right? And so it's oscillating and never has a limit. So anytime you see that with a sine, cosine, or just oscillating behavior, then that would also be undefined. Okay, so what I just explained to you are like numbers 16 to 21 on page 55. So if you turn to that page and you just want to take a look, what you're doing there is you are finding, they ask you to find the limit as it approaches a certain value. And so that's all you're doing is you're just finding, is there a limit? And if there's not a limit, because you might approach these 3 different situations, you're going to explain why it does not exist. All right, now the last set of homework problems, we're going to add a little bonus feature to it. So the last set of homework problems are going to be 23 and 24 on page 56, but I want to show you how to do those. So this is going to look very similar to what your homework on those questions are, but let me show you how to do them. So we already did A, B, and C as the limit approaches things, right? So we already did this back on example 1 on page 3 or on the front of page 2. And so just to recap this, the limit as the function is approaching -4 was 2. As it approaches 6, it was 5. And as it approached 1, it was undefined. So now here we are actually, instead of just finding the limit, we want to find the value. So what does the value mean, or what is the value at a specific function, which you've done before? It's basically you plug it in and you find the value. We don't have an equation here. So we want to find what is the value of these functions at certain points. So let's start with this one. So they want to know what is the value. So right here, what is the value of the function at -4? So if I go to -4 and I look at this point here, it's an open circle, right? So open circle means that it is not equal to anything because it's open. So it's not equal. So that means there is no value. It's not 0, because if it was 0, it would be down here. So there is no value at -4, so it would be undefined. I know that was kind of a tough one to start with. So let me show you the next one, and then maybe it'll make a little sense. So the next one we're looking at is the function at 6. So what is it equal to at 6? So if we go to 6 and we go up here, like, oh, okay, so there was an open hole here, so it's not equal to 5, but look at that. Actually, the value at 6 is equal to 2, because that's where the closed circle is at the 0.62. So the value of the function at 6 is 2, but the limit of the function at 6 is 5. That's a mind blow, right? All right, let's keep practicing. So the next one, okay, so the limit as we approached 1, remember we said it was undefined because it had this gap in it, this hole. Not a hole, it's not a hole, it's a gap. But what would the value at 1 be? So again, here's 1. And if we look at this 1 here, you can see this guy, this is an open hole, so it's not equal to -2. Here's your closed hole. So 1 is equal to 4. So the value of the function at 1 is equal to the number 4. Okay, so this is kind of a mind blow, is to separate the difference. What is the limit of the function versus what is the value of the function? All right, let's try one more example and then hopefully you'll catch on. So let's go to the last example, example number 2 on your back page. So if you want, you can take a minute. If you want to try these by yourself, you can pause me and you can see how you're doing. If you want to take guesses first before I go over this. Okay, so let's start with A. So we want to find the limit as this function approaches -1. So we're going to go to x is -1. And then we're looking at the function as it approaches -1. So here's the function approaching -1. And hopefully you're seeing that as it approaches -1, it's coming from 2 different places. There's a jump, there's a hole from what, -2 to 0. There's a big jump, discontinuity. So that means that this is undefined. The limit is undefined at -1. Now, what about a value at -1? So where is the function valued at -1? So where is the filled in hole, basically? So the filled in hole at -1 is at -2. So that means the value of the function at -1 is -2. So the limit does not exist. It is undefined at -1 because we have a jump here, but the value is -2 because that's where my hole is at. Okay, let's try the next one. Now the limit as we approach -2. All right, so let's find -2, 1, 2, -2. Okay, so we're not concerned about this hole, but that'll be important for the next one. We're concerned about the graph itself. So here it's approaching -2. Oh, yay. Okay, so it's approaching the same point. So it means we have a limit and it's approaching 1, 2, 3. So it looks like it's approaching at 3.5, my y value. So your limit as it approaches -2 is 3.5. And now what is the value? So where is the hole filled in at -2? And here is where it's filled in. So it's filled in at -2 comma 0. So your y value at -2 is 0. Okay, so the limit as it approaches -2 is 3.5. That's where my hole is. But this filled in circle is at 0. Okay, next one, let's go to 4. Let's try this one. All right, the limit as we approach +4, 1, 2, 3, 4, okay. So as we can see in this graph, we have it approaching something over here, and then we have an unbounded graph over here. So unbounded, we have an asymptote, which means that it is undefined. Undefined with an asymptote. So undefined at 4. Now, what is the value at 4? So is there a closed circle at the value x equals 4? And there is one right here. So it would be at 0. Okay, last but not least is we're going to go to -5. So 1, 2, 3, 4, 5. So we're going to go to -5. And we want to know the value, so not the limit, because hopefully you'll see the limit here does not exist because there's a big jump at -5. So there's no limit here. What is the value at -5? So again, if you look here, there is no closed circle. These are both open circles. There's no dots along here along -5 to show that there's a value. So that means it is undefined at -5. Okay, hopefully that gave you a few practice problems. We will go over this again in class. So just to be clear, your homework is to right here finish. You're on page 55 and 56. There is 1, 2, 3, 4, about 7 to 8 problems for you to complete and bring to class when I see you again. Please let me know if you have any questions.